welcome to part 3, the tangent function. Yay, more graphing, everybody's favorite. Here you get to do the graph of a tangent. So I again use the x-axis in degrees, and we're going to plot that versus y equals tan theta. If you want to pause the video for a moment and scale your axes like I've done in the picture, feel free. If not, then I guess I'm just going to roll on with graphing, and you can follow along. Okay, so I'm going to plot my points in different color. And so 0 is 0, goes at the origin. 30 degrees, so that'd be about here, and 0.577, so graph it about there. Okay, 45 and 1, so right about there. 60 and about 1.7, just under 1.75. And at 90 it's undefined. So to show undefined on a graph, we would draw a vertical asymptote. Right about here at 90 degrees. Okay, there would be another vertical asymptote over here at 270 degrees, so I'm going to draw that one in as well. Okay, good. And so now after the asymptote, we're going to go to 120, so that's at negative 1.7. So that would be right about here. Okay, 135 would be at negative 1, right there. Okay, maybe a little more this way. Okay. Good. Okay. 150, we're at 0.577. So that's just a little more than that. At 180, we're back at the x-axis. We see the x-axis again here at 360, so I'm just going to draw that one in. Okay, and then we go to 110, so that would be here, and again just a little bit above the axis. Followed by 225, which would put us right about here at negative 1 or positive 1, and 240 right just there. Okay, and at negative 300 we're down here again. Good. At negative 315 we're at negative 1, and at 330 we are just above that, 0.5, negative 0.5, and again at 0. Okay, we're going to connect the dots with a nice smooth curve, just like we did before. And then we're going to look at some of the characteristics of the tangent function. It seems to be quite a different animal than the sine and cosines. They look pretty similar to each other, but this one certainly does not look similar to them. Okay, so we're going to determine the following from the graph. The x-intercept. Alright, so there's 3 in our picture at 0, at 180, and 360. Okay, the y-intercept is at the origin, so that's when y is 0. The equation of the asymptotes, we're at 90, and again at 270. So x equals 90, and x equals 270. The period for this function. Okay, so the first time it crosses the x-axis and goes up is at 0. The next time it crosses the x-axis and goes up is at 180. It does it again at 360, so we can clearly state that the period is between from 0 to 180, or just 180 degrees. The median, okay, it looks like the middle of the graph is on the x-axis. Okay, so that's when y is 0. Okay. The domain, because we have vertical asymptotes, our domain has been restricted, so the domain will equal x cannot be 90 and any 180 degrees from 90, so that's okay. And the range will be, it goes infinitely in both the x and y directions, So y belongs to reals. Okay, so how is the graph of the tangent different from those of sinusoidal functions? Okay, so again, if you want to think about this, just pause the video. If not, I guess just listen up. So, how are they different? Well, the tangent graph obviously has asymptotes, which is not something that you see on the sine and cosine graphs. But there's no maximum in, and the domain and range are definitely different. Okay, are different. Good. Great. Let's take a look at some trig problem solving with tangent. Examples. A simple sundial has a gnomon 10 centimeters tall. So when you think about your sundial, okay, there's your plate that the sundial lies on, and then you have this triangle guy that sticks up, okay, and that is the gnomon, okay, and its height is 10 centimeters, and as the sun hits it, it casts a shadow around it, okay? All right, if the angle of the sun with respect to the gnomon changes from negative 75 at 7 in the morning to positive 75 at 5 in the evening, then write an equation for the length of the shadow in terms of the angle of the sun. Okay, so y is equal to the height of the gnomon, which is 10 tan theta. All right, determine the length of the shadow at 4 p.m. Now, our shadow goes, because remember, there's nothing to do with time in your formula in part A, so we have to figure out how time is related to the angles. Well, our times go from 7 a.m. to 5 p.m., which is a difference of 10 hours. Our angle goes from negative 75 degrees to positive 75 degrees, which is an angle of 150 degrees. So, we go 150 degrees in 10 hours, then that means we're going 15 degrees every hour. Okay, so 4 o'clock p.m. then is 1 hour less than 5 p.m. So then 75 degrees take away 15 degrees would put us at 65 degrees. 60 degrees, sorry. Okay, so then y equals 10 tan theta, which is 10 tan 60, which is 17.3 centimeters. Make sure your calculator is in degree mode for that one. Okay, part C, at what times will the shadow be 10 centimeters long? So, here we have negative 75 degrees to positive 75 degrees, okay? And so we're going to figure out what time it's going to be, so I need to figure out what angle would make that, and then go from there based on our 15-degree markers. Okay, so y equals 10 tan theta. So if y is 10, then that would be equal to 10 tan theta. Divide both sides by 10. Now, when does theta equal 1? It equals 1 at 45 degrees. So if you go tan negative 1 of 1, or if you want to look at your tangent unit circle, then you sure can find out that tan of 45 is 1. Okay, now, because this is a symmetrical scale, if this is happening at positive 45 degrees, then it's also going to be happening at negative 45 degrees. Okay? So, 75 take away 45, that's 2 increments of 15 degrees each. So if we're starting at 5 p.m. and 2 increments before that, that would put us at 3 p.m. So at 3 o'clock, we would have a shadow that's 10 centimeters long. On the other side, if we start at 7 and again go up by 2 increments to get to 45 degrees, then that would put us at 9 a.m. So at 7 p.m., at 9 a.m. and at 3 p.m., the gnomon shadow will be 10 centimeters long. Okay. If you want some more practice to go along with this, you're going to take a look at page 262 in your textbook and do the questions as assigned. Again, don't forget to show your practice to your teacher when you're finished and before you head on to the last part in Chapter 5.